Hey, good morning, good afternoon, everyone. My name is Niranjan or Niro. I'm the Central AI Product Manager here at Siemens EDA, and I'm really excited to be in San Jose this week for NVIDIA GTC. And today I'm joined by two great product leaders from Siemens and NVIDIA. You should, Avinash, you want to introduce yourself?
Sure, yeah, happy to be here. Hey everyone, I'm Avinash. I lead our GenAI software co-design with our key enterprise ISVs and data platforms. Very nice to be here.
Satish?
Okay, thanks for inviting us, and it's a great event in the GTC. So my name is Satish, and I'm the head of product for the centralized AI team at Siemens EDA, and excited to be here.
Yeah, and we have both of Avinash and Satish here to discuss an exciting topic about agentic AI in chip design and CAE applications. And basically, we want to cover is three things, like why is this the need of the hour? What's NVIDIA and Siemens doing to address these problems, and what are we doing together? And then also dive deep a bit in the Fuse ED AI agent, which we just launched today, probably like a few hours ago here. And so I think we should get started. I think the first thing I would like to know is, Avinash, why do you think agentic AI in chip design or CAE or computer-aided engineering is like the need of the hour?
Yeah, I think it's no surprise that the EDA workflows and the chip design workflows, they're fairly arduous. The dev cycles take forever, and given the complexity of the chips in terms of designing the modern AI systems has increased substantially. But then our team sizes have not, right? So the time to market pressure and the amount of work that needs to get per unit time has kind of increased so much. And I know that we started building copilots to kind of solve this problem of efficiency, but it's become evident in the recent months and years that that's not sufficient. We need something beyond copilots, beyond something that just assists. We need something that can autonomously plan, orchestrate, and even execute some of the tasks. While the engineers are sleeping, the work gets done. So that's the kind of solution that we need. So I guess in that sense, then agentic workflows, or rather the long-running agentic systems, have become kind of inevitable to solve this problem.
Yeah, no, that makes sense. And as I was thinking about it, I was wondering, in the last 1 year, we have had so much development in terms of AI solutions and agents. So I was wondering, why can't we use just, those off-the-shelf or third-party solutions for, engineering fields like chip design? What do you think, Satish?
I think it's a great question. So number one thing is the consumer AI solution that's available. It's really not focused on physics, right? What we deal with EDA, electronic design automation, for chip design workflows is all based on physics. And most of the consumer off-the-shelf solutions are kind of cloud-based, and they're kind of more of a generic in terms of knowledge-wise. The second most important thing is chip design and EDA in general is a lot more domain knowledge is needed. So you got to be really good in your domain, and it's very specific, right, in semiconductor domain. So that domain expertise needs to be brought in for these agentic AI solutions to be. I would say the third one, what we want to do is, there's a lot more, so we are coming up with a lot more MCPs and so forth, but, connecting a chip design involves a lot more connected tools. So you usually have this context saturation issues that happens in hallucinations, which is a strict no-no, right? So in the kind of saying in chip design is, if you're 98% accurate, you're a failure, right? So that's the thing, right? So the problem statement is different. And the most important thing I see is, it's heavily, I would say, customized solution. So you look at one company, NVIDIA, you look at any other companies in semiconductor designing chips, from all the way from start to finish, it's a lot more domain specific or customization is required, and off-the-shelf solutions don't help. Last but not the least is safety and security. We really need to make sure that, first of all, it's secure, and we safeguard the IPs of all the key, our customers, mutual customers being NVIDIA and everyone who's designing chips, and want to make sure that we provide the right access to people that is needed to get the job done, right? But overall, these are all the challenges we see that commercial grade solutions cannot really address. But the most important thing is, anything we do in agentic AI flows, we have to be, I would say, industrial grade AI, but we call it industrial grade AI, which means it needs to be accurate all the time.
No, I think that makes sense. So essentially what we're trying to say is like in EDA, you have so much domain knowledge that needs to be there. The agents needs to, interact with like the compute clusters, the LSF servers and these things. It has a bunch of MCP tools. So all those things are going to make it very difficult for generic solutions to get adopted. You also mentioned security, and that that made me think, how is NVIDIA approaching these domain-specific agentic solutions? Like, what is your strategy or solutions? Maybe you can give few examples.
Yeah, absolutely. I think the most important thing to understand is we tackle this problem in a very full stack manner. So it's end to end. So right above the compute layer is data at the center of everything. So we have sophisticated tooling to make sure that since domain specificity is the main problem we spoke about, right? So we make that data usable for the partners that we collaborate with, right? So that means there's data scarcity, there's data sensitivity. So how do you clean that, make it available for post-training tasks, for evals, and so on and so forth. So to that effect, then we have the NEMO data designer, NEMO safe synthesizer, and a bunch of like peripheral kind of tooling to make sure that the data is usable. At the heart of all the tooling is the models, obviously, because they are the agents, they're central to everything. So for that, we have our NVIDIA Nemotron models, and we closely collaborate with the Siemens team to make sure that they're usable, right? So Nemotron models are our open source models, which are designed to be world-class at being intelligent, efficient, and truly open. By truly open, I mean that we open source not just the checkpoints, but also the pre-training data, all the post-training data, all the recipes, toolings, and whatnot. So you can take it and just customize it however you would like. But then in order to customize it, really, you need software and libraries and everything else to manage that end-to-end agent lifecycle, right? And to make it more efficient for the specific GPU that you're using. To do that, NEMO provides a set of libraries, whether that's NEMO Agent Toolkit for profiling, telemetry, and then observability layer of it. And then secondly, we also have NEMO Reinforcement Learning, NEMO Gym, to kind of design these post-training tasks. So literally, it's like end-to-end. And then finally, at the end of it is obviously the inference. So we have a hardened, secure runtime to make sure that these are performant on the GPUs and wherever you want to run, actually, whether that's on-prem or whichever cloud you have affinity to.
No, I think that makes sense. I really like your bucketing of like the NIMs, the NEMO, and the Nemotron models, and the entire stack. Like it's pretty comprehensive, to put it that way. Coming back to how Siemens is approaching, I know in the last 1 year, Siemens EDA specifically has worked a lot on the Fuse EDA system, and we also saw the launch of Fuse EDA agent today. So maybe Satish, if you could describe, the Siemens' approach or strategy towards agentic automation, that would be great.
I think it's a great question, right? So one of the things that we observed from the customers were like, they really wanted a solution that's open, customizable, and secure. So we launched Fuse EDA AI system last year at the Design Automation Conference, which is a comprehensive generative and agentic AI system that covers the entire semiconductor and PCB workflows, which are very complex workflows, end to end, right? All the way from spec to manufacturing sign-off. And one of the key things we focused on was it needs to be open, which means that we built in all the capabilities, hooks and so forth, that customers can connect any part of the workflow data. For example, they can connect their own data lake. They can actually have, use NVIDIA's Nemotron models as one of the key LLMs. They can connect to their own third-party vendor tools or their own in-house tool automation, plus provide secure. So with Fuse EDA AI system, we made it open, we made it secure, and we made it customizable so that the customers can really get their job done. Today, just a few hours back, Niro, like you mentioned, right? 30 minutes back, we launched Fuse EDA AI agent, partnering with NVIDIA, NVIDIA's NIM Agentic Toolkit, and everything else that we are working with them. And what we have done is the next evolution of the Fuse EDA AI system, where we are essentially, Fuse AI agent is essentially orchestrating multiple agents that could do different parts of the subflow automation, orchestrating so that we do the end-to-end design cycle all the way from start to finish. What this means, an example is, let's say you're starting a design start in a company, you can essentially use the Fuse EDA agent to start all the way from architectural exploration to your RTL exploration, RTL generation, synthesis, place and route, so sign off all the way up to manufacturing. Think about an agent kind of making sure that it observes everything, it provides you an instant feedback that are much more intuitive, and it's got a lot of good recursive loops so that it kind of has a feedback loop to solve all the key problems that comes in EDA. So those are the two key things that we are approaching. Always being open, coming up with customizable solutions that are more secure, but of course we bring in the EDA domain expertise and the physical engines with it.
No, I think that strategy makes sense. Like, using Fuse as that baseline infrastructure, which is open, customizable, modular, has a bunch of these components of like, RAG and multimodal access to different EDA file formats and things, and then building the orchestration sort of an EDA Fuse agent on top of it to manage multiple tools, trigger subflows and flows really makes sense. I want to go a bit deeper on the Fuse agent specifically here. So could you talk a bit more about what makes the Fuse agent a bit special, maybe in terms of how it's handling the MCP context crowding problem, how is it handling the connections to LSF servers that where the EDA tools are executed, maybe how is it handling the design intelligence required to handle different EDA file formats depending on what part of the flow. So maybe if you can elaborate on these points.
I think one of the key things that like any other design workflows in semiconductor design, an EDA workflow consists of multiple products or tools, right? So it's a numerous number of tool callings, a lot more function calling and so forth. So one of the key things is it needs to support MCP. All the products within Siemens EDA, they are kind of MCP enabled. So Fuse by itself can be a server or a client, right? So kind of made orchestrated in that way. The second thing what we did is we made sure that we kind of did some good innovation in terms of how do you solve this context saturation problem with MCPs. What we have seen in general is if you kind of do it on your own, every user has these multiple MCP servers that kind of gets crowded. And of course, you mentioned about context saturation and hallucination, which is a strict no-no. So we worked with NVIDIA's Nemo toolkit and Agentic toolkit. So one of the things that we have within Fuse agent is what we call dynamic tool calling and tool discovery. What this means is we have Fuse as a single centralized MCP server. We use queries in an intelligent way and identify the tool calling so that dynamically kind of registers the MCP server for any relevant flows. And then it goes and has a very intelligent data lake, which is essentially what we call it design intelligence, so which is essentially understands the entire EDA formats and modular and modalities and so forth. And the third thing is we have a very good orchestrator built in within the Fuse agent that essentially manages. So we call it like, essentially it's like instead of human in the loop, it's more kind of a human on the loop with Fuse agent that kind of makes sure that your flows work as it is and gives you the right answer all the time.
No, I think that makes sense. So, in a sense, it's basically having a unified MCP layer for all the tools. That really makes sense. Having sort of RAG for tools is like in the approach we're going, and also having like a registry for all the compute clusters. So when you have to execute a tool, it's a bit easier. I think these are great innovations. Like there's a lot of pipelining that goes under the hood that the user doesn't see. Coming back to you, Avinash, like I think at the Consumer Electronics Show a few months back, NVIDIA CEO Jensen Huang and Siemens CEO Roland Busch were talking about our collaboration on AI native EDA, and our teams have been collaborating a lot on the Fuse platform as well as the NVIDIA AI infrastructure. So could you describe some of what we've been doing collaboratively? Maybe give examples of, you mentioned Nemotron models that we've been using.
Of course, first of all, congrats on the launch. It's been an incredibly rewarding exercise. Lots of hard work by both the teams. So yeah, I mean, we've been working with the Siemens EDA team for the last, I think, 2 years almost at this point. And the first thing we started, as I said, we started building copilots, but then we very quickly realized that the problem was more complex. So in the recent months, we've been deploying and testing the Nemotron models to make sure that it improves upon the baseline. And earlier this year, we got the results that we got 2x throughput and 33% accuracy lift for the same model size range, and also 97% precision parity with frontier models. And I think those results we were surprised ourselves having looked at that. But it kind of also corroborated some of the internal research that we've been doing. So that was an off-the-shelf model, our Nemotron 3 nano model. I think where we're going next is to customize that, post-train those models to make them more accurate, because the problem set is now more complex than what we were doing earlier. So post-training could involve multiple things. It could be supervised fine-tuning, or it could be like reinforcement learning. And to do reinforcement learning in a large multi-agent system that has hundreds to thousands of tools requires a brand new environment setup, right? For that, we're going to be using NemoGym to extract those trajectories and then simulate those environments to do effective RL runs. So that's the other direction that we're going to be taking together. Other than that, I think because the system has grown a lot in complexity, we also are trying to introduce this concept of a router. I'm sure you have your orchestration and routers already, but then the problem kind of changes when we think at scale. So routing so that the model is not just accurate, but also the cheapest and the most performant one for the setup that we have in place. That's the second thing that we're going to be working on. And then lastly, we are going to be co-designing on the Nemo agent toolkit side.
Yep.
So brand new integrations to make sure that the observability kind of meets your standards. Yep. And also we're able to profile and have the telemetry kind of traced and tracked and make sure, like, find out the bottlenecks and see where we can optimize further. So those are the three overarching directions we're going to take.
No, I think those make sense, Avinash, and it's been an exciting journey to work with your team as well. The way I look at it is, like, if I take a step back, if I have to build like a mental map of an architecture diagram, if you will, it's like, a query comes in, we have a sort of an intelligent router, as you mentioned. That router, depending on what the chip designer's query is routing it to either a frontier model, which is really great at coding, like, GPT-5, Claude Sonnet, or routing it to like a fine-tuned Nemotron model that is really good at, say, operating or tool calling one of the Siemens EDA tools, because it's, we have done the fine-tuning on that. And then having the observability on, like, how chip designers interact, what is the agent thinking, what are the thinking traces, what are the different options and tool calls, and having that data to, keep refining. So I think that really makes sense. Now, basically, I think we have a lot of exciting things we have discussed, like future looking, what we have currently. I was trying to understand where are we seeing value, Satish, from customers' point of view. I think we have been working with few customers in the last year or so. What is some of the feedback you have been getting from them? Where are they seeing value essentially?
I think the value is in two key areas, right? One of the key things that we believe is with agentic AI, we are definitely increasing productivity. Productivity is increased almost 5x, 10x fold, which means that every designer or anyone who's on doing chips, designing chips, verification of chips, they are able to do a lot more. Like you mentioned, Avinash, like the time to market is still getting down, and the number of design starts are increasing thanks to NVIDIA and other companies. Like, there's a lot more AI inference chips and everything else is going on. So the productivity, it's a productivity game, and with Fuse, we are seeing on and constantly customers saying that it makes their job easier, they're able to do more, all the way across, all the way from, we just launched Questa 1 Agentic Toolkit a few months back with NVIDIA as one of the key partners, where we are able to do, we are essentially able to write assertions automatically, generate assertions, and being able to verify the entire RTL verification loop, which is the most huge, longest pole in terms of doing design. So a lot more innovation happening, it's productivity. Third thing, second thing we are seeing is because of productivity, we are seeing improved design quality. Huge improvement in design quality, which means that with Agentic Toolkit, with the amount of AI that's being enabled in terms of efficiency, the engineers are exploring design spaces which were not thought before, right? So they're able to get to their PPA, which is the power, performance, area constraints, in a much more intuitive way, and able to meet their targets. So the design quality and definitely productivity is a key thing. We worked with many customers. NVIDIA is one of the key customers as well, right? All the way across our product line, from Caliber, Questa, Solido, and Veloce, and so forth. Every one of them, they say that we are, essentially the copilot, the in-tool AI, the Gen AI, definitely improved in terms of the knowledge graph, in terms of how much productivity they do. With agentic capability that we are bringing in with Fuse Agent, they're actually able to use their knowledge in a way that can get the job done much more efficiently.
Makes sense.
So great. It's an exciting time. We are learning every time. Every month, Avinash is coming up with new products and new key capabilities. That's actually helping us overall, right? Thanks to NVIDIA.
Yeah. No, I think that's great to hear. Happy customers and happy users is what we all strive for. I know we are close to time. What is one takeaway that you want the audience to go away with?
You're at GTC, you're going to have many takeaways, I'm going to warn you. But I think the one takeaway which we've learned recently is that secure, long-running agents will be the norm in terms of automating end-to-end agentic tasks. I think we're past the age of copilots, and it's going to be long-running agents now.
Oh, that makes sense. And it has been exciting to talk to both of you. So essentially what I'm hearing is 4 things, right? Doing agentic automation in EDA or chip design is the need of the hour, but it's freakishly difficult. You need to have purpose-built solutions for it, and Siemens is Fuse EDA system, and Fuse EDA agent is essentially purpose-built to solve this challenge. And then Siemens EDA team and the NVIDIA team are working day and night to improve these solutions. Scale it easily. Make it more secure and things, and it seems like we have an exciting future ahead for us. And
it is, yeah.
Yeah, thanks for joining me.
Thank you.
Yeah, enjoy the rest of the time in GTC.
Thanks, Avinash.
Thank
you.
Yeah.